banget.
Okay, hello everyone. Before I begin with the presentation, I would like to ask a simple question. If you get a small cut on your hand today, how long do you think it will take time to heal? Maybe a few days or about a week, right? Now imagine having a wound that stays open for months and refuses to heal properly. This is a common problem experienced by many diabetic patients. Today, I will present my topic, the role of mesenchymal stem cells in enhancing diabetic wound healing and tissue regeneration. My name is Christopher Serjudan from Biomedicine 2025, and during this presentation, I will explain why diabetic wounds are difficult to heal and what mesenchymal stem cells are, how they help improve wound healing, and what current research says about their future potential. By the end of this presentation, I hope you guys will understand why stem cell therapy has attracted so much attention in regenerative medicine. Okay, let's start with the problem itself. Most people know diabetes as a disease related to high blood sugar levels. However, diabetes affects much more than just blood sugar. One of its most serious complications is diabetic wounds. These wounds can become chronic wounds, meaning they remain open for a very long time and heal very slowly. Why is healing being delayed? There are several reasons. First, diabetic patients often experience chronic inflammation. Normally, inflammation is beneficial because it helps the body respond to injury. However, in diabetic wounds, inflammation continues longer than it should. Second, diabetes damages blood vessels and reduces blood circulation. This means that oxygen and nutrients cannot reach the wound effectively. Let me ask you something. Can a construction site build a house without enough building materials? Of course not. The same things happen in wound healing. Without enough oxygen and nutrients, tissue repair becomes much slower. Third, fibroblasts, which are important cells responsible for producing collagen and repairing tissue, that did not function properly in diabetic conditions. Finally, high blood sugar levels and nerve damage known as neuropathy further disrupt the healing process. Because all of because of all these factors, conventional treatments often struggle to fully solve this problem. This is why scientists have started exploring regenerative medicine's approaches such as mesenchymal stem cells. Now let's talk about the main focus of this presentation. How many of you guys have heard of stem cells before? Stem cells are unique cells because they have the ability to develop into different types of specialized cells. Mesenchymal stem cells, or MSCs, are one type of stem cell that can be found in bone marrow, and then adipose tissue or fat tissue, and several other sources. What makes MSCs special is not only their ability to become different cell types. In fact, many researchers believe their greatest benefit comes from the substance they release. MSCs produce growth factors, cytokines, signaling molecules, and extracellular vesicles. These substances help cells communicate with one another and coordinate tissue repair. Another important feature is that MSCs can regulate the immune system and control inflammation. Instead of targeting only one part of the healing processes, MSCs influence multiple stages simultaneously. Think of MSCs as a project manager. A project manager does not build everything alone. Instead, they coordinate workers, provide instruction, solve problems, and ensure the project runs smoothly. Similarly, MSCs help coordinate the healing process by influencing many different cells and biological pathways. Because of this unique ability, MSCs have become one of the most promising tools in regenerative medicine. Now, the first mechanism through which MSCs help wound healing is inflammation regulation. As I mentioned earlier, chronic inflammation is one of the main reasons diabetic wounds heal slowly. Normally, inflammation occurs during the early stage of healings to remove damaged tissue and protect against infection. After that, inflammation should decrease so the repair process can begin. However, diabetic wounds often become stuck in the inflammatory stage. Like imagine being stuck in the traffic, like you want to move forward, but everything is blocked. This is similar to what happens during chronic inflammations. The wound cannot process efficiently to the next healing stage. MSCs are here to help solve this problem. Research has shown that MSCs reduce pro-inflammatory cytokines, which are molecules that promote inflammation. At the same time, MSCs increase anti-inflammatory mediators that support tissue repair. MSCs can also communicate directly with immune cells and help regulate their activity. As a result, the wound environment becomes more balanced and stable. Studies by Karimineko and colleagues demonstrated the immunomodulatory properties of MSCs, while Gao and colleagues later provide experimental evidence showing reductions in inflammatory markers after MSC treatment. By reducing excessive inflammations, MSCs create conditions that are much more favorable for healing. The second major mechanism is improving blood vessels formation, also known as angiogenesis. Let's think about this logically. What do all living cells need in order to survive? The answer is oxygen and nutrients. Without these resources, cells cannot function properly. In diabetic wounds, poor circulation limits oxygen and nutrient delivery. This creates an unhealthy environment where healing becomes difficult. MSCs help by reducing growth factors, especially vascular endothelial growth factor or VEGF. VEGF stimulates the formation of new blood vessels around the wound area. These new blood vessels improve circulation and increase the delivery of oxygen and nutrients. Think of blood vessels as roads. If a city only has a few roads, traffic becomes congested and supplies arrive slowly. But if more roads are built, transportation becomes faster and more efficient. The same principle applies to wound healing. More blood vessels mean better delivery of essential materials needed for repair. Experimental studies have shown increased blood vessels formations in MSC-treated wounds compared to untreated wounds. This improved circulation significantly contributes to faster healing. Okay, now that inflammation is controlled and blood supply is improved, the next step is rebuilding damaged tissue. This is where MSCs contribute even further. One important cell involved in tissue repair is the fibroblasts. Fibroblasts produce collagen, which provides structure and strength to heal the tissue. Unfortunately, fibroblast function is often impaired in diabetic wounds. MSCs stimulate fibroblast activities and encourage their growth. They also increase collagen production. Collagen acts as like the framework of a building. Without a strong framework, the structure cannot be completed properly. MSCs also promote reepithelializations, which is the formation of new skins over the wound surface. In addition, they support wound contraction, helping the wound close more quickly. Research has shown that wounds treated with MSCs often close faster and show better tissue organizations compared to untreated wounds. This demonstrates that MSCs play an important role throughout multiple stages of healing. Now, let's briefly review the studies included in this literature review. The selected studies came from different years and research approaches. Some studies were review articles that summarized previous findings. Others were experimental studies that directly investigated MSC's effect. Karimineko and colleagues highlighted that the regenerative and immune-regulating properties of MSCs. Power and colleagues focus on factors responsible for delayed diabetic wound healing. Coe and colleagues discuss regenerative treatment strategies and emphasize the importance of angiogenesis and tissue repair. Gao and colleagues provide direct evidence that MSCs reduce inflammation and improve blood vessel formations. Jere and colleagues demonstrated the importance of fibroblast function in tissue regeneration. Although the studies used different methods, all of them pointed toward the same conclusion. MSCs can positively influence diabetic wound healing through multiple biological mechanisms. Even though the findings are promising, there are still some limitations. First, many studies were conducted using animal models or laboratory conditions. Human biology is much more complex, so successful results in animals do not always guarantee success in patients. Second, the number of studies is still relatively limited. Different researchers are also use different MSC sources, dosages, and delivery methods. This makes direct comparison result, and it's difficult to analyze. Another challenge is the cost. Producing stem cells and maintaining their quality can be expensive. Researchers must also address concerns regarding long-term safety and treatment standardizations. Looking ahead, future research should focus on large-scale clinical trials involving by human patients. Scientists also need to establish standardized experiments and treatment protocols and develop more affordable therapies. If this challenge can be overcome, MSC-based therapies may become a valuable treatment option in the future. Okay, so to conclude, mesenchymal stem cells show strong potential for improving diabetic wound healing. Unlike conventional treatments that mainly address symptoms, MSCs target several root causes of delayed healing. They reduce excessive inflammation, they promote the formation of new blood vessels through VEGF production, and they enhance tissue regeneration by stimulating fibroblasts, collagen production, and new skin formation. Together, these mechanisms help wounds heal more efficiently. Although more clinical evidence is still needed, current research consistently supports the positive role of MSCs in diabetic wound healing. This makes MSCs one of the most promising approaches in regenerative medicine today. So that's all about my presentation, and thank you very much for your attention.